All right, we're on page 2 of our ticket to retake. 8, 9, 10. This looks kind of complicated. What do you guys think? All right, so when I see a picture like this, I was talking about it on the last problem. I do like to just start figuring out things I can figure out and then see if I'm able to answer these questions. So to make sense of this picture, I am going to focus on different triangles at different times. So the first thing that I'm noticing is that 60 degrees. 60 degrees is this angle right here. That's 60 degrees. It is part of this triangle. And so if I filter out everything else, what I notice about this triangle is we have two congruent sides, which makes this an isosceles triangle. When you have an isosceles triangle, two congruent sides, bonus, you get two congruent angles. So from here to here and from here to here, those angles are congruent. Because we know that 60-degree angle, we can find these missing angles. We can say 180 minus the 60 degrees that we know, which is 120. So I have 120 degrees left for this angle and this angle. And then I'm going to divide that by 2. And we're figuring out that each of those is 60 degrees. So that's interesting, right? Because if these are all 60-degree angles, 60 degrees, 60 degrees, now I can reclassify this and say, well, now this is an equilateral triangle, right? Okay, speaking of equilateral triangles, if I come over here, I'm going to highlight a different triangle. This triangle here, do you guys see how there are 3 congruent sides marked? This side is congruent to this side, is congruent to this side. That makes this an equilateral triangle, and what we want to remember about equilateral triangles is the bonus you get with that are 3 congruent angles. And those 3 congruent angles will all be 60 degrees. Okay, so let's see if we can figure out any more information. And again, I might be figuring out more than what I need, but sometimes this just helps me to get to what we're looking for. So the next thing that my brain notices is this right angle right here. This right angle is right here. And I can see that the right angle is split into 2 smaller angles, where this one is 60 degrees. This one we don't know, but if combined they make a right angle, which is 90 degrees. I just know if I take 90 degrees, subtract 60, I'm going to get this. So what is 90 minus 60? That's going to be 30 degrees. All right, well, why don't we see if we have found enough information to answer the questions, or maybe we'll come back and look at some more. All right, so first thing we need is the measure of angle PTQ. So remember the vertex is at T, and the angle goes from P to T to Q and then back to T. So P, T, Q. Okay, well, I know from here to here is 60, but we haven't figured out just this part of it yet. So we'll come back to that. Let's see if we know what QTR is. So angle QTR, remember the middle letter T is our vertex. So it's going to be the here at T. Oh, look at these are all at T. So if I go from Q to T to R, this is this skinny little one right here. Well, we haven't figured that one out either. All right. Do we know from angle PTS PTS is at T again. And if I go from P to T to S, all right, this one we do know. And yeah, this one we do know. So we said that from here to here was 60, and then from here to here was 60. So PTS is this big angle. We have 60 degrees and 60 degrees. So that is going to give us, we'll just add those together and get 120 degrees. All right, and then there's something else that my brain didn't see right away that will help us answer the other two questions. Do you guys see segment QP and TP are congruent? Okay, so I'm just going to highlight the rest of that triangle. So here's a triangle with two congruent sides. When you have a triangle with two congruent sides, that's isosceles. Bonus with an isosceles triangle is two congruent angles. So the angles that are congruent are not where our two congruent sides meet, but your other angles here and here. So this is starting to get a little trickier to see, but here's one angle of that isosceles triangle, and the other one is just this part of that, all that's happening there at T, just that little part. So can we figure out those angles? Well, we know that this whole triangle, those angles add up to 180 degrees, and one of those angles is 90 degrees. So we can take 180, subtract 90. That leaves us with 90 degrees left for these two angles that are congruent. So to figure out those, we will just divide by 2, and those are each going to be 45-degree angles. All right, I'm going to try to write this in. There's not a ton of space. So this angle is 45, and then this angle, that's real hard to see. Okay, I just zoomed way in. Can you guys see where I wrote this 45 degrees right here? Okay, so this angle is 45. From here to here is 60. So do you see how 60 degrees, this 60 degrees, this kind of pinkish one, is broken into two smaller angles? So if we take the whole angle 60 degrees, let's remove the 45-degree angle. That's going to leave us with this skinny little sliver of an angle. So 60 minus 45 is 15 degrees. So that is going to be a 15 right in there. All right, I think, will we be able to see this as I zoom out? I think we have figured out what we need to answer the question. All right, so angle PTQ, again, the vertex is at T. So T has a bunch of angles happening. So P to T to Q. So P, T, Q is this angle right here, which is that 45 degrees. All right, so we got that one is 45 degrees. Then we have QTR, so vertex is at T, but from Q, T to R, that's that skinny little one. We just figured that out. I was zoomed way in. That's that 15 degrees. Okay, well that didn't take any time at all, did it? All right, so that was a good challenge right there. Nice job for following along with me. All right, number 11, what is the measure of angle JKL? So again, we're using 3 letters to name an angle. So the vertex is at K, which is this angle right here. So what's the measure of that angle? Well, what do we know about the triangle? As we look at the triangle, we might notice that we have 1, 2, 3 congruent sides, Anytime you have three congruent sides, that is an equilateral triangle. And bonus, we get three congruent angles. If all those angles have to be congruent, to figure out what that is, we just want to divide by 3 evenly. Or you guys just might already have that down, that equilateral triangles have 60-degree angles. So the measure of angle JKL is equal to 60 degrees. So this is 60 degrees, 60 degrees, 60 degrees. All right, number 12, are the two triangles congruent? If so, which congruence theorem can be used? So let me remind you of what our congruence theorems are. We have 5 total, and we learned about them over 3 different lessons. So first we learned about side, 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 and side, angle, side. So side, angle, side is when you have 2 sides congruent and the included angle. Then we learned about angle, side, angle, which is 2 angles in the included side, and then angle, angle, side, 2 angles in a non-included side. And then the very last one we learned about was our HL, that stands for hypotenuse leg. Let's just make a note, this one is only for right triangles. So if we're not dealing with a right triangle, we don't want to try to use that one. Now we might have a right triangle and use one of these other congruence theorems, but if you're trying to use HL, you can only use it if you have a right triangle. All right, so let's see, what do we think about number 12? I can see that we have this side congruent to this side. We have this side is congruent to this side, and then we also have a congruent angle. These angles are congruent. So we have 2 sides and an angle. Do you see how where these 2 sides meet at this angle? That's what an included angle looks like. So these are the 2 sides in the included angle, which is the angle in between them. So that congruence theorem is going to be our 2 sides, but an included angle, so we would say side, angle, side. All right, number 13, if I look at that, I can see some congruencies right away. We've got a pair of congruent sides and another pair of congruent sides and a third pair of congruent sides. So that's what side, side, side looks like. But I do want to point out on this one, we have another possibility. Sometimes we have to look for more congruencies that they're not going to mark for us. So some things that will not be marked for us are vertical angles, a shared side, or an overlapping side or angle. In this case, we do have vertical angles right here. So when we have vertical angles, now what we can use is we have 2 sides, and where our sides meet, this angle is congruent to these 2 sides, and that angle, that is that side, angle, side, 2 sides in the included angle. So both of these, I'm going to say or, these are both perfectly acceptable answers. Your eyes might have caught the side, side, side right away, but if you are just trained in on, do I have vertical angles? Mark them congruent if you do. You might have seen that first. Okay, so number 14, we have some congruencies. We have this side congruent to this side. Oh, we got another side congruent. And then we do have a congruent angle. So anytime that we have 2 sides in an angle, it has to be a side, angle, side combination, 2 sides in the included angle. If we have 2 sides in a non-included angle, that's not enough to prove that the triangles are congruent. So the question here is we have 2 sides. Is this the included angle? Well, the included angle is going to be between the 2 sides. So it's going to be where your 2 sides meet. So angle F actually is the included angle, not angle E. So had angle F been marked congruent, we would have side, angle, side, but because it's not, we would say not enough information. All right, so number 15, we've got some congruencies. We got this side congruent to this side. This side is congruent to this side. So we have two sides congruent. Might be tempting to say not enough information, but we have to always be on the lookout for vertical angles, a shared side, overlapping sides or angles. So we do have vertical angles here. Those are going to be our congruent angles that are vertical. So now we have two sides, and this is the included side. So two sides in the included side is side, angle, side. So those are congruent by side, angle, side. Okay, so number 16, well, we got some congruencies again. This side is congruent to this side. We have an angle right here, congruent to this angle. So we have a side and an angle. Not enough information right now, unless there's more that we can mark congruent. So again, we look for vertical angles, a shared side, or overlapping sides or angles. So here we have vertical angles again. I hope that's getting easier for us to spot. When we have those vertical angles, there's a third congruency. So we have two angles and this side. So anytime you have two angles and a side, is the side included or is the side not included? Two angles, the included side is going to be the side in between them, which is not the side that's marked congruent. So this is two angles and a non-included side, which is angle, angle, side. All right, so number 17, they gave us some additional information. They said that AD bisects angle A. So angle A right here is getting bisected. That means cut in half evenly to these two angles, which means these two angles will be congruent. So we can go ahead and mark that congruency. Another thing I want to notice is we have a right angle and this straight line. So these two angles are a linear pair. So if that's 90 degrees, this will be 90 degrees because those two angles will add up to 180. So let's go ahead and mark that 90 degrees. Okay, what do we have? We have two congruent angles up here. We have two congruent angles here. So we have two angles. Is there anything else that's congruent that we are allowed to mark on our own? Again, look for vertical angles. We don't have any vertical angles in this picture. Look for a shared side. Do you guys see how AD is part of triangle ADC and it's part of triangle ADB? So that is a shared side. AD is congruent to AD in both triangles. So we're just going to mark it congruent to itself. That's essentially what we're doing there. All right, so now we have the two angles. We have a side. Anytime you have two angles and a side, it could be angle, angle, side, or angle, side, angle. So what we want to notice here is we have two angles, and then the side in between them is marked congruent. So this is an included side, which means it will be angle, side, angle.